Hello and welcome to this presentation, How to Eat the Elephant. But this is part 2 on the strategy of how to eat the elephant. My name is Jason Tranter, the Managing Director and Founder of Mobius Institute. Okay, so in this presentation we're going to again just remind you of what the elephant is and then go through a number of steps that we believe you need to go through in order to implement a reliability improvement program. This is part 2. In part 1 we talked about what I think is the most important point, and that is that you have to develop a reliability culture in your plant. People need to really believe in this, and ultimately the best situation is where they want to change and want these changes to take place and will be supportive. But at the very least you don't want them resisting the sorts of changes. But ultimately, these changes that we're going to talk about, and I've sort of listed some of them there, it's not something that you can do in a very short time. You can't just turn around and say, right, we're going to make all these changes, starting from today. It is a case of both gaining everyone's support and cooperation and everything, but at the same time rolling this out slowly so that the changes can sort of take place and people can get used to the new way before you move on and implement the next step. So let's have a look. How do you eat the elephant? I think it's a good idea to have first seen the other one, but to be honest, you could watch this one first and it stands alone. But in case you didn't see the other one, what is it that we are trying to eat when we talk metaphorically about eating an elephant? Well, we want to improve reliability. We want the ability to run a plant with the lowest costs and the highest availability. We want to make changes that will improve the OEE and that will reduce the costs of operating the plant. Those costs range from, well, potentially labour costs, but certainly spare parts costs, energy costs and other costs, and then with the higher availability we can even look at increasing the capacity of the plant with the existing equipment. Anyway, that's not really the point of this presentation. Now, when we talk about eating the elephant, it's really just that we've got this big challenge. If you look at the uptime elements, there are all these individual blocks, these elements you're supposed to take care of, all of these individual issues that need to be dealt with, from RCM to vibration analysis, improving the planning and scheduling and spares management and all of these different areas. And whether you focus your attention on the uptime elements or what I'll present to you in a moment, the issue is that it can seem daunting. It can seem like that's a lot of things to master on the one hand and implement on the other. And what I hope to do in this presentation is explain that there's a systematic way of doing it. It's not something you have to do in the next 6 months or in the next even 2 years. But anyway, some of those elements that we just looked at, we have to look at implementing some sort of condition monitoring so that we can get an early warning of those problems that are developing. We want to improve the maintenance practices, using precision maintenance practices in terms of lubrication, alignment, balancing, installing bearings, tightening bolts, etc., so that those faults detected with condition monitoring are less likely to occur in the first place. We need to improve the way the operators are operating the equipment, because that really has a large impact on reliability, and also perhaps get the operators involved in some of those condition monitoring activities. We need to take a close look at reliability centered maintenance and PM optimization as well. Just how detailed, that's something we'll talk about a bit later. We need to look at root cause failure analysis, planning and scheduling, etc. And that's not a complete list. But that can appear a little daunting. So the big question is, where do you start? Part of the challenge is that depending on your particular situation, your starting point might be different to another person's. It really all depends on which elements that we'll identify in a moment have already been put in place. But that's fine. You I think it's worth looking at all of the issues you need to look at, but if you can check off some to say, oh, we've already got that in place, and hey, we're already doing that, then great, you've already progressed a little, and then you can find out where your individual starting point is. The one thing I want to clarify though is when I say, what your situation is. Sometimes, in fact, quite frequently, I hear comments that, well, our industry or our company is unique, and therefore that all these sorts of techniques we talk about are somehow, they don't apply to your plant. Well, I disagree. We will present a number of elements that need to be taken care of, and I would argue that if you had genuinely taken care of all those issues, then you would have no reason to be listening to this presentation right now. You wouldn't have a reliability problem, or it would be in very specific areas with some sort of unique equipment, and maybe you need to do some sort of specialist study, a very detailed RCM or FMEA just on that piece of equipment. And okay, that's something you may need to do, but that would be an organization that has very good reliability but just little problems in unique areas, in specific areas. Most companies have much bigger problems than that, and therefore what I'm about to say should be very relevant. So let's just have a look at the big picture first. The elements that I think everyone needs to consider. The first is we'll call it the reliability strategy or the maintenance strategy, however you want to look at it. And there is another webinar movie that goes through this in more detail. In fact, I think we've got a short one and one that I believe took me about an hour to really go through. So if you're interested in this, please just take a look at that movie so we can move through this a bit more quickly. The bottom line is, we should be in a position where we can look at every single asset in our plant, motors, pumps, fans, electrical equipment and so on, and be able to say, okay, we have decided that for certain equipment we will let it run to failure because failure does not have any effect on downtime, on environmental health or safety, and there's a low cost associated with the loss of that piece of equipment, and there's no ripple effect, there's no secondary damage. So we will identify those. We will then also identify which pieces of equipment we can utilize condition-based maintenance. We have to know what the failure modes are, we have to know the approximate PF interval, and we have to know how those failure modes can be detected, and then we can implement the correct condition monitoring technologies with measurements at the correct interval. And we also then will identify probably a fraction of the assets. I mean, this will be a fraction and this will be a fraction of the assets where we can genuinely say we have a pretty good idea that because of the wear out of a particular component or a build up of material or whatever it is, that we can say we can schedule maintenance based on the operating hours or volume of production created or calendar days, and we can perform that maintenance and know that we will be either replacing a component or overhauling a machine or performing a cleaning job or something like that, and it will be necessary. If that's not the case and we can detect it, then we're going to use inspections or condition monitoring techniques, and in certain situations we're just going to redesign. Now, how did we make those decisions? We're going to go through a process of making sure we understand what our assets are, what the criticality of those assets are. Now, this is an important point, but really it's not the point of this particular discussion. Ultimately, we need to know what the failure modes are, the effects of those failures, how detectable they are, and more. Again, not really the point of this discussion. We do ultimately want to know this information. The point that I will get to, I promise, is that we're developing this plan of where we want to be. What I'll get onto soon is how we get there. Now, we also have issues related to changing the way we design and purchase spares and new equipment, how we manage spares and inventory, planning and scheduling, precision skills, operator care, and lubricating the machine and so on. And we can't get there without having the leadership in place. So we need to get that senior leadership. We need to develop the committee, which is generally a good idea, to have a group of people to say, well, this is what we're trying to achieve, and this is how we're going to get there. But as per the other presentation, there's a lot of sort of human management things that we need to take care of. Anyway, so that's what we're doing here, and then for continuous improvement, we will learn from the failures that occur, we will learn why, we will find the root cause, we'll find out what we can do to prevent it from happening again, and thus we will have continuous improvement. We'll track KPIs and promote the program internally, do some of the things we talked about in the other presentation, and generally keep refining our criticality ranking and getting a better understand of our failure modes. We can start doing more of a reliability study to understand mean time between failure and so on. So in, well, my opinion, this is ultimately what you need to aim for, improvements in all this area. We could talk more about that. The question is, how do you do it? Because you can look at something like this and think, right, we need to tackle all of these elements at once, or which one comes first, and how do we possibly make all of these changes? And so, in this presentation, I'd like to propose what that sequence should be. How do you get there from here? Now, the illustration you see on the screen, which I'm about to expand upon quite a bit, shows a number of steps. And what we have done, and I'll just say, we did this as part of our training program, our e-learning training program called iLearn Reliability. In fact, it's not quite complete. It's about to go into iLearn Reliability. Whereas iLearn Reliability, presents the diagram you saw on the previous slide, and we teach a lot about how you get there. We wanted to lay it out in little chunks. So I apologize, I'm talking about a commercial product. That's not really the point. I'm about to tell you how to do it as well, and you haven't bought it. But I'm just kind of warning you, because sometimes when I show this diagram and lay it all out, it can look intimidating. It's like, oh boy, you find out that the elephant is perhaps bigger than you thought it was. I really hope you don't feel that way. Anyway, let's just get into it, and you can decide, and hopefully I will show you that it is very manageable and not something that you should be intimidated by. So what we're going to do is we're going to start at the start and just say we have to do some foundational tasks. We need some things in place, ideally, so that we can move forward with this whole thing. And so what we need to do is build support for the Reliability Improvement Program. We need that core team, and we need to be thinking about how we're going to transform the culture. Now, as per the other presentation, sometimes it doesn't hurt to just tackle a few of the little block diagrams I mentioned just earlier, and just say, let's get a little, a few runs on the board, so to speak, so that we can, sell that to management. But I would just say that really what we want to do is identify that champion, or the people within the organization that are really going to drive this. Ideally, we will gain the support from the highest levels. So I say the C level, Chief Financial Officer, Chief Reliability Officer, whatever roles just at that sort of high level in the organization. Each of these steps you may not do right at the start. In my opinion, you will never succeed with the whole reliability improvement program until you do actually have all of these in place. But that doesn't mean you can't begin to make progress without all of these in place. But the point is that ideally, there's probably going to be one person that really is sort of the lead of all of this. That may be you. you're going to hopefully form a group. So it's not just you. There's a group of people, and that group of people, might involve someone from operations and maintenance and reliability and possibly quality and safety. And together, because you can show that unity, that we're all in it together, you can all look at all of these issues with that perspective, it'll move forward. Look, there are other steps we could talk about here, but we'll be here forever if I go through every single step in the sort of detail that I would like. That is certainly something that you need to begin with. Then we need to put some of the sort of structural elements in place. We really want to assess the plant's current status, or the facility's current status, identify the gaps, and put in place the measures to enable progress to be measured. So, as a part of that, I think the next step, once you've sort of got the core support and the group together, you then say, right, understanding the need to develop that reliability culture, which I talk about a lot in the other presentation. We're going to develop our training plan. We're going to think about, okay, what knowledge and skills do we already have? You might already have a good condition monitoring group, or you might have good maintenance planning and scheduling, or you need to sort of review where you are now, and therefore identify where the gaps are and where you need to go further. So that's part of what this is. Benchmarking, where you compare what you're doing now and what you're achieving now against either your best ever results or industry best practice. Develop those KPIs. I talked about that in the other presentation a little bit. It's always a good idea for people to understand what your business is and where you actually add value to your customers. What are the real core things here, and do the production and then operating people understand that, and does the maintenance group really understand that, and are you working together for that process? But as part of this, and they sort of go in order, you should then perform a plant walkthrough and just begin that process of identifying where your problems probably exist. So you go through the plant, and of course there's a lot of detail we could go through there, but you can identify just where, either because of the cleanliness, or there's leaks, or there's the alignment practices aren't good, and you can look at breathers on gearboxes, and there's a whole lot of things. Again, there's a lot of detail I would love to go into with each of these, but really that's a good place to start. Now you sort of know where you are, and from that and from what we're about to talk about, you kind of know what the journey ahead looks like. But there are certain fundamental elements that you need to have in place before you can really do anything. You need to make sure that the maintenance and operations group are communicating with each other. It's a good idea to have those morning meetings to make sure communications are strong. Make sure that maintenance and production really sort of agree on the plans, and as part of that, you need to develop the master asset list and have some idea of criticality. Now we'll be talking about criticality more a little later on. With each of these elements that you need to consider, like if you cast your mind back to the reliability roadmap that I drew, or the uptime elements, there are blocks there, but each block doesn't have to be done as a single effort. You can look at a lot of those as something that you might take a step towards performing that task. So for example, condition monitoring, which I'll mention in just a moment. We talk about vibration analysis. Your starting point might be quite simple. Your starting point might be to get consultants involved to just start taking some measurements around the plant, or get a very simple meter. Now that is not the solution, but it's better than the nothing that you might be doing now. And again, you've got to listen to everything that I'm talking about here and think about, well, whether you agree with it, it's fair to say, but also whether you are already doing those things, and you'll be able to check off these items. In fact, that's the way this works in the product. You get to just tick each one and say, yeah, I've done that, I've done that, I've done that. But basically, one of those things is, have you considered the asset criticality ranking at all? Even if you don't do a formal one to begin with, you need that master asset list. Anyway, these are all elements that are good to have at the start. We will do a more elaborate job later, but this is just a good starting point. But again, if you don't have that communication sort of set up, that is really something that needs to be addressed. Now, at this stage too, we need to have in place some at least basic maintenance planning and scheduling. Now, sometimes I've heard people debate whether you really need planners and any scheduling. Well, the maintenance work goes so much more smoothly, and someone might look at this and say, oh, but we can't invest in that. Another long story, but you can take a team of 15 people who work with performing these maintenance tasks, and they will be far more efficient if you take one of those people out and make them the planner. The remaining 14 will be far more efficient than the 15 ever were. It's not a cost. It's not a new employee you have to hire. You're not losing a person with those skills. You're gaining productivity. But you need to have some sort of maintenance management in place. You need some way to generate work requests. You need some of that planning and scheduling. You should have some way to check whether the work that's being planned is actually being done. You need to look at the question of inventory and spares, so that if you're going to identify problems, that you've actually got the spares to perform that work. And that's an important one. Sometimes people have lists of what they think is in inventory, but the inventory is all over the place. What's in there isn't necessarily in good condition. What's in the records as being there isn't actually there. There are some things there that aren't in the records. There's parts squirreled away in different places around the plant. It's time to start getting that in under control. And at this stage you might have a basic computerized maintenance management system. I mean, it could be just a spreadsheet. Now again, some of you will be listening to this and think, oh geez, that's a long time ago. But I also know there's a lot of organizations that haven't done anything in this area. So that's the point. We're starting from here, and we're getting each of these areas under control, step by little step. Now, I think it's a good idea at this stage to get some sort of basic condition-based maintenance in place. So we should have some condition monitoring. Condition monitoring is so effective at giving us an early warning of the problems. Now you'll notice, by the way, that these two are sort of in parallel. We're going to start this journey first, but really these two are in parallel. You can see them, and in fact some of these are in parallel with those two as well. So they're functionally separate sorts of issues, but you can see they're going on in parallel. And soon we'll get into more detailed CBM. Later on you'll see how this all pans out. But the thought here is, and I just mentioned it before, we're going to start some condition monitoring. We want to get a warning of problems to help with our planning and scheduling, rather than just being caught by surprise all the time. But this could be very simple. It could be a very simple in-house program with a basic vibration meter and a simple infrared camera maybe, and ultrasound product. Not very expensive, not very complicated, just a good place to start. Or you may use some outside consultants to come in and do specific tasks and do more detailed analysis, or some work that does take more skill. This can be the starting point. Not the end point, but to try right at the start to implement a full-blown condition monitoring program with properly trained and certified people is too much to start with. So let's just start small. Let's just get the ball rolling and learn from that experience. The other thing is, if you use consultants, make sure that as part of the agreement, when you take over, you get the database and you get the history of what they've been doing and how they set up the program and so on. And then we want to start with this basic failure mode symptoms analysis. We're not yet ready perhaps to do the full RCM sort of failure modes analysis. Perhaps. Remember, some of this is in parallel. Notice that this is sort of overlapping. We've done a basic sort of walkthrough. Where was the plant walkthrough? We did do we have started to think about these things. Where are our problems? Where is our low-hanging fruit? What is our bad actor list? However you want to call it, we've got to start that process. But now's a time when we can, step that up a little further and start talking about improving reliability and identifying the problems that exist and start making some changes to get some wins. And we can separate that out. Again, we're sort of going to go through but performing walkthroughs more frequently, involving operators, involving mechanics and so on, and saying this is what we have to do. Let's do the walkthrough and ask people, what do they know about the equipment? What are their problems? What where do their challenges lie, and all that sort of thing, and learn from that and act on it. I talked about that in the other presentation. But we're going to go through and develop that bad actor list. We're going to fix it and provide the feedback, and we can start recording the mean time between failure information. Now, at this stage, we still may have a lot of reliability problems, but it doesn't hurt to start recording this information at this stage. The key is to record information that we can use, not just machine broke, bearing failed, just like really vague information. We do want to know that it failed and when it failed, and how long it took to repair it and when we got it up and running again. But we want to keep more detailed information so that we know what the failure was. Not just bearing failed, or certainly not just machine failed. We want to know it was the bearing, and we'd like to know why. And we don't have to get too elaborate at this stage. This is sort of getting into root cause failure analysis. But gee, with some things, it's not rocket science. You can look at the surface of the bearing and you can tell, oh, there's corrosion, there's electrical fluting, there's misalignment. You can tell quite a lot. And at this stage, if you like, you can start a sort of a basic Pareto analysis. You can start to say, well, how frequently are we seeing different sorts of faults? And even though you might think, well, some things are more common, some things are less common, you can, put the numbers down and you will start to find that perhaps 20% of the equipment's giving you 80% of the problems. There's a lot more we could discuss there, but anyway. Now this is not all happening overnight. This is not all happening in the first year. Well, some of this we'll be making some progress through a lot of these things actually in the first year. But we're just going to take those baby steps. But now we can start looking at the reliability strategy in more detail. We've made a good start, but now we're going to go further. This is where we're going to be more formal. Now, if you like it, I haven't said this is the RCM process. The whole topic of RCM is really best left for another day, but the elements of RCM and the output of RCM, understanding the maintenance tasks that we need to perform, understanding where we can apply condition monitoring and so on, those sorts of things we need to do. I've called it accelerated RCM. It's not sort of a trademark thing. It's just that a formal RCM process on all of your assets is rarely warranted. It can take a very long time. Meanwhile, you may not be making much improvement with reliability. So we can go through a bit more of a streamlined process, but we ideally should have a better criticality ranking than what we had here. By this stage, everyone should be tuned in and understanding issues like risk and the detectability and the reliability and the costs of failure and the impact on quality and safety. People should be thinking more that way, so we can do a more formal asset criticality ranking. Using that, we might approach the top 10. Look, it really depends on your industry, lives at risk, safety issues and all that, but it might be the top 5%, it might be the top 15 or 20% of assets where you might go a more formal RCM process to really make sure you understand the failure modes. But it's good to start with that criticality ranking. Now we can start to design our condition monitoring program because we have that information. We should really know what technologies we need to use, which pieces of equipment we're going to monitor, which technologies are needed, how often we're taking measurements, that sort of stuff. If we have been performing any sort of planned maintenance, if we do have maintenance tasks that came because of OEM warranty requirements or regulatory issues or just a lot of stuff that we do because we've just always done it, well, it's not a bad time to also then look at PM optimization. Let's make sure all of those maintenance tasks are adding value and they are necessary. We can then, based on this information, we can say, well, hey, do we have any equipment that's too critical to let fail, but we can't detect the failure modes or certain important common failure modes, and we can't prevent them with some time-based activity? We need to look at replacing them or redesigning them. We can look at inventory, and we can look at QA, QC standards, and that ranges, from acceptance testing, although we'll talk more about that a bit later, but just, when we do some work on a machine, let's check that it's good. When we buy new equipment, let's check that it's good. Now, again, we've got this overlap because, this we'll call it precision maintenance. Really, I've sort of drawn it here because here we can identify what these maintenance tasks are. But really, there's a lot of things like precision shaft alignment, precision lubrication, precision balancing. You don't need to study, all your assets and so on. You really can get started pretty early thinking about the maintenance tasks that can be improved upon to improve reliability. There's always the question of cost-benefit analysis and that sort of thing. But what we're going to do is just improve our maintenance practices. Improve our planning and developing the job kits, precision installation of bearings, and including the alignment and balances and tightness and tolerance and lubrication and so on. Now our maintenance should be working much better than it ever did before, and our work should be very, very good. And all of these activities, aligning the machines properly, belts and shafts, and all of these aspects here, all will mean that reliability will be improved, and we will be seeing fewer failures. And people who used to be involved just with reactive tasks, as you move through this cycle here, more and more of their activities are going to be proactive in nature, doing things so that we don't have those failures. They're not being fired, we are just using them to improve the health of the equipment and reduce the likelihood of failure. So, precision maintenance, and of course condition-based maintenance. Now remember, we started doing this back here, and of course it doesn't have to be, well now we have to wait all this time to do this, but a proper condition monitoring program just takes a bit more thought than, hey, it vibrates, so we'll measure vibration. It could get hot, so we'll use thermography. Ideally there's a bit more thought, and that thought process is here, and that's why we can design the condition monitoring program, because we know something more about our failure modes and PF intervals and things like that. So we can do our vibration analysis and ultrasound and all the other ones there, and now something like non-destructive testing, which can have regulations involved. That sort of thing should have been going on for a long time, but there are lots of optional NDT tests that you could be performing that maybe you haven't been required to perform, and you might start performing those at this point. And I'll introduce defect elimination now as well. Now, to me, defect elimination is really something that should be on your mind from the start, but there's a lot going on, so we'll leave some of these issues until we really have time for it. We can't just make lots and lots of changes. too quickly. But just as I've said here, for example, precision lubrication, and we're trying to do our work better back here, now's the time where we can hopefully have a better idea of why equipment's failing and what causes it to fail, and therefore identify some of these particular, well, I'll call them opportunities to improve the reliability. Now, again, I would like to see this grey, this arrow extend way back here, just as I've extended that one. Potentially these are things that you can think about right from the very start. Particularly that one, that's something that you can think about right from day one. You don't put contaminated lubricant into a machine, and you don't leave contaminated lubricant in the machine. So you look at filtration, you look at storage, and so on. And the question is, when do you do it? Well, there are a lot of other things that we can do and that we need to have in place perhaps before we focus on that heavily. But certainly with some of these other ones, when we start looking at the design practices and the purchase specifications to make sure that the procurement department can't just choose the cheapest motor or replacement lubricant or whatever without thinking about the costs, the true costs of that spare that's just being bought, or replacement piece of equipment. So the design, we put in place acceptance testing. We make sure that when it's being transported or stored, it's not being damaged. We're eliminating contamination. We're eliminating or reducing resonance. And very importantly, which again is like this, something we could start thinking about earlier, we want to make sure we're operating the equipment properly. It's no point doing all these other things if the equipment's not being operated properly. So, finally we can get into the question of how to optimize all that, but let's not spend a lot of time on that right now. The bottom line is that this is all an ongoing process. We need some of these baseline things in place, but a lot of these are sort of being replaced by the better way to do it. We started doing vibration here, we're doing it better there. We start making some decisions here, but at this stage is where you might start thinking about better maintenance reliability, a better CMMS system, and you may even be thinking about ISO 55000 certification and some of those sorts of issues. But you certainly need to be thinking about continuous improvement and root cause failure analysis. And so this is where we can say, right, we're going to consider the failure modes and report on them. We can start doing reliability analysis so that we have a better understanding of what the availability is likely to be, where I might have weaknesses with my redundancy and with my process, better understand what my bad actors are and that sort of thing. I've got KPIs here. Remember, we established them earlier. But we need to communicate them. We can repeat the benchmarking process, we can perform internal audits, but we need to continually record the KPIs and report on them so management know what a great job we're doing. Now, I am sure it's possible that you would look at all that and think, oh, I had no idea the elephant was so big. Wow, that's a lot of stuff. I hope that in my quick run through you actually feel, you know what, this is all manageable. Not in the next month, but I would like to think that I didn't say a single thing in there that you shouldn't think is beyond your ability. We're not, with some of these sorts of activities here, we're not having to do some sort of analysis that takes a super duper expert. It's about thinking, why does this equipment fail? You might have some specialist equipment and you can get some specialized help, but you probably got a lot of motors, fans, pumps, compressors, turbines and other machines, and it's well documented what the failure modes are. It's well documented what the condition monitoring tasks should be. Okay, you may need some training, so that the people are good with vibration analysis and skilled with these other technologies and so on. okay, well, book the course. What can I say? It's all doable. The people who have mastered all of this stuff, they're not Rhodes scholars with IQs of 200 and all this sort of thing. They're normal people, but they took it bit by bit by bit by bit by bit. It's not. I think it helps to understand what the ultimate challenge is and what you're going to be trying to do, and the fact that you're going to keep refining this process. But you've got to see that it just takes certain building blocks. You need to do certain things before you really should try and do other things. But as I said at the start, you might go through this and say, you know what? Now with some of these we can sort of actually go through a more detailed checklist. Like for each of these elements we actually have a more detailed process where we can go through and identify whether we have really checked off each of the parts that you need, and what progress have you made through establishing the steering committee or whatever. So there are some individual little details to help you get there. But as I say, I hope seeing all this isn't intimidating. I hope that you see it as at least revealing what's behind the curtain, but seeing that each of those little building blocks are very manageable. And from an investment point of view, a lot of them, walkthroughs, and there's a lot of things there that actually don't take much investment. It's just how you use your time, and that is sometimes, the big question. Oh, use my time. I'm so busy all the time, but a lot of people are busy, and the maintenance folk, craftspeople, electricians, and so on are busy because you're not doing these things, and it's a catch-22. So as you start to do these things, you will gradually, okay, here we haven't actually improved anything. We do this as sort of baseline work to make sure that all the rest of the plan's going to work. So all this stuff here, particularly the green, that's why it's in green, and then these fundamental elements, you put those in place bit by bit. But as you do it, you will start to see that there are fewer failures, and therefore there are people available to take on more of these tasks. And because you are making these improvements, and craftspeople are working on more proactive tasks than reactive tasks, you'll see improvements in those KPIs, and hopefully then management will say, yeah, we'll let you bring in an outside consultant to take some vibration readings, let's say, or we'll buy that intermediate level vibration meter. And as I say, some of this doesn't necessarily take a lot of your time, or certainly doesn't take a lot of expense. Anyway, probably enough said, I think. So, in conclusion, even though I've just shown you that great big chart, please don't overestimate the challenge. You just need to break it up into those little chunks and do them one by one, check them off, get a really good feeling as you check them off, get everyone on side. But please don't think that I'm saying that this is, real easy. Yes, the elephant is big, yes, there's a challenge. That's what we've got to do. I don't think it's worth overcomplicating the issue either. It's easy to think that it's going to take all kinds of specialist training and consultants and equipment and all that sort of stuff. I hope that as we went through that presentation and that diagram there, that you feel, okay, it is manageable. Take a deep breath. Let's start at item number 1 and start getting through this. No better time than today. And having said that, don't scare the people in the boardroom, with the elephant. I'm not saying you're going to hide it from them, what the big picture is, but you can certainly talk in terms of, reduction in costs, improvements in availability, improvements in safety and environmental incidents, reduced risk, all the things that the board wants to know about, that the shareholders want to know about, or the government if it's a government facility or something like that. you don't need to sort of let them see behind the cape, behind the curtain right at the start. Don't make them feel like, wow, this is a huge, huge job or something like that. Anyway, bottom line is you just need to break it up into those little bits and take them on. Identify which parts you've actually already got under control and where you just need to improve things a little bit. Okay, so thank you for viewing this presentation. I hope you found it useful. I hope you don't feel that the job's too big. I hope you see that it is manageable and you can manage it. Now, everything I hope I just said you would see is non-commercial in nature. I will just mention, now I'm putting my sales hat on, I will just mention that the reason we have that big diagram, in fact I think I mentioned that, the big diagram and the roadmap to reliability and all this stuff is because we have a training product that is there to equip you to do all those things. So, you know, the professional development version is there for you as an individual. You know, maybe you want to master all these things and be more confident with each of those little, you know, uptime elements and little building blocks that I mentioned, so that you're more comfortable with that before you embark upon a program. Maybe you just want to be, you know, CRL or CMRP certified. I forgot to put that on my name there, but that's, you know, what I've been through. Or you can use this and everyone in the plant can be educated to the level that they need to be. We've got toolbox talks for the operators and millwrights, craftspeople and so on, to get them on side, to get some buy-in and demystify all these things. We've got management briefings, manager briefings for senior management to understand the financial benefits. We've got skills training for all the planners and schedulers and all those people. Anyway, on our website, if you go there /reliability or just look for I Learn Reliability, it's all explained. And of course contact us, you know, if you write to that email address, we can certainly give you more information. But as I say, we created the training product because we saw the need. You know, for 30 years, just speaking personally, I've seen companies try and fail to whether it's just getting even a good condition monitoring program running or tackling reliability. But when you look at the companies that were successful, that's basically the path they went through. Or let's just say that they took a different path. It was a really rough road, and in hindsight, it's like, yes, that's what we needed to have done. We did try and skip a few steps. It really caused us a lot of pain. We really need to have had some of those building blocks in place before we tried to do that. Anyway, I really hope that this presentation has been helpful. Thanks for listening, and let us know if we can help you with anything.